Hello friends, today we are going to study the spectroscopy. There are different spectroscopies which are in the syllabus, that is the H1NMR, C13, mass spectroscopy, UV spectroscopy and IR spectroscopies. In the semesters we are going to study the only theoretical parts, and in the next semester we are going to study the numerical and applied part of this theory. So the today's topic is the introductions of the second substituent into the monosubstituted benzene's derivatives. May be different, maybe as the different the color, and it may be lighter the colors. Discuss the pi to pi star. This is all about the colors and color related with the UV spectroscopy. Color are imparted to the solutions to the if it is fall into the region of the UV regions. The pi to pi star transitions in the benzene required higher energy and are absorbed in the UV regions. Hence, the benzene is the colorless. But in nitrobenzene, due to the addition of the chromophore, there is the chromophore interactions, and the absorptions just extends into the visible regions, and hence it has the pale colors. Whereas in the paranitroanilines, the conjugation is exchange energy pi to pi star transitions reduce, and thus is absorbed fully in the visible regions, and hence it has the deepen yellow colors. Benzenes, nitrobenzenes, paranitrobenzenes color also changes colorless, pale yellow and deep yellow color. What are the different types of the conjugations which spectrum can detect, and what is the benzenoid bond? The UV spectroscopy does not provide the information about the sigma bond, therefore the saturated compounds like alkane cannot be analyzed. But UV spectrums following are the compounds which give the conjugations and give the spectrum. Absorption bond of the aliphatic diene having the shorter wavelength than those of the alicyclic dienes. Is the butadienes and 1,3-butadienes. The absorption bond of homoannular dienes are higher wavelength than those of the heteroannular dienes. Absorption band of the cyclohexanes having the higher lambda mag value than those of the absorption band of the cyclobutanes. In the aromatic chromo of the benzenes, naphthalines and the phenanthrines are given as follow. Aromatic compound gives an important absorption band at 254 nanometer due to the pi to pi star transitions, which is called as benzenoid bond. Principle of mass spectroscopy. In the mass spectrum, the organic molecules are bombarded with high energy beam 70 electron volt. Energy of electrons is for the work comes usually chemical bond energy in the organic molecules. Due to energy of electron, molecule get energized and there is a extensive fragmentations. These fragmentations are mostly positive ions, each of which has the particular mass to charge ratio. Various ionic fragments separated according to their m by e values of the acting in various magnetic field. Plot showing the relations of the relative intensity of the singlet and at a different m by E value is called as mass spectrum. The largest positive called base peak is the intensity is known as the 100% intensity, and intensity of the other are expressed relative to it. What is the molecular ion peak? Explain its importance. Due to the impact of the electron, neutral molecules loses electron, resulting in the radical chain. Radical cations, molecules plus electrons, molecule cations plus 2 electrons, radical cations and molecular ions. For example, molecules react with the electrons, gives the molecular ions or the M plus ions. Energy required to remove the electrons depends on the type of electron, that is lone pair, conjugated pi electrons, non-conjugated pi electrons, sigma bonds, molecular ions. Molecular ions represented unfragmented molecules, and hence it has some weight to the original molecules. Hence, location of the molecule ion peak is very important. Next is the state and explain the nitrogen rule with example. Explain the mass spectrum fragmentation of the 2,3-dimethyl butanes M by E71, M by E43. Explain the mass spectrum fragmentation of 2-methyl butane. If the compound reacted with electrons give the cations 7 electron hole to give the fragments, that is M by E15 and M by E71s. Next is the explain the mass spectrum fragmentation of 2-methyl butanes. In the structure of 2-methyl butanes, reacted with the electron give the plus ions, molecular ions. Fragmentation give the CS3 dot and the molecular ion peak we will get. So in the spectroscopy we have studied the electromagnetic spectrums. Then we have studied the unit of the wavelengths, quantization of the energy, absorption phenomena, general principle of absorption spectroscopy, principles of the mass spectroscopy, and the fragmentation rules. This part we have studies in these sections. And the energy required to remove the electrons depends upon the type of electrons, that is the lone pair, less than conjugated pi electrons, less than the non-conjugated pi electrons, less than sigma bond molecular ion, represented unfragmented molecules, and hence it has some weight to the original molecules. Hence the location of the molecular ion pitch is very important. This is the amount of energy required to electrons in the series. Highest amount of energy required for the breaking of the sigma bonds, then the non-conjugated pi electrons, then the conjugated pi electrons, and the least amount of energy required to remove the electron, that is from the lone pair of electrons. Lone pair of electrons are loosely held, not involved in the bonding, hence required a less amount of energy. So from the next today's onwards, we will take the revision lectures of the organic chemistry. Friends, do the practice of all the part we have covered in earlier lectures. Thank you very much.